Hello again. Kenny Kent here, the math tutor. So, find all the zeros of the given function. Here's a function. The zeros are just what we can plug in for x to get 0. Now we can spend hours on end just plugging in numbers to see what makes 0, or we can start by finding what numbers, like a range of numbers we can work with to start off that we can plug in. So to find the range of numbers, our first step is to take the constant, the last term with no x term, and put all the factors of the constant over the leading coefficient, which is the number in front of the first x, in this case 1, since there's nothing there. So we put all the factors of 4, positive and negative 1, positive and negative 2, positive and negative 4 over all the factors of 1, positive and negative 1. Okay? Putting those over that, we get all the possible values we can use. Since it's all over 1, it's pretty much positive and negative 1, positive and negative 2, positive and negative 4. Okay? So here's what we're going to plug in to find for the zeros. So we just took infinite numbers and just narrowed it down to 6. Okay? Now, how we find the zeros is we do synthetic division for each of these, and what we're looking for is a remainder of 0. So if we have a remainder of anything other than 0, we know it's not going to work. So we'll start with 1, and you'll see how this works as I go along. So positive 1, I'm setting up a synthetic division. You know how to do this. 5, 4, 4. All right, bring the first term down, and now I go to town. Well, this one is 1. 5, 5, 10, 10, 14. Well, I know that's not going to give me 0, so that doesn't work. Now I do negative 1. I'm looking for what's going to give me 0 right here. Negative 1, negative 1, 3, negative 3, 2, negative 2, 2, negative 2, 2, close but no cigar. Let's do positive 2. 1, 4, 5, 4, 4, 2, 6, 12, 17, 34. Well, we know it's not going to get 0, so we can stop there. Negative 2, 1, 4, 5, 4, 4, 1, negative 2, so 2. Negative 4, 1, negative 2, 2. 2 times negative 2, negative 4. Bingo! Negative 2 is one of our factors. We're on the right track. Okay, I skipped through the rest of the synthetic division because you know how to do it. We went through positive negative 1, positive negative 2, positive negative 4. The only factor I found that worked and had a remainder of 0 was negative 2. So, are we done yet? No, because it's a degree of 4. We know we're going to have about 2 to 4 solutions. We only have 1 so far. Well, I used all the possible values. What do I do now? Well, we take what's left over, right? After doing this, I just filled in the constant x, x squared, x cubed, etc. We pulled out that x plus 2. Or it's the opposite. So now we have this left to work with. We're done with that. We pulled the 2 out. This is what left we have to work with. What we can do is either factor or use the quadratic formula. Now, we can't use the quadratic formula because it's a degree 3. We only use the quadratic formula if we have x squared in the mix, but we have x cubed. What we can do is start to factor. And with this, we're probably going to factor by grouping. And you should know how to do this. Factor by grouping is normally when I have 4 terms, I can separate them out and pull out what works with each of them. For instance, what do these two have in common that I can pull out? X squared. So x squared, when I pull out x squared, what's left? X plus 2. Now with 1x plus 2, can I pull anything out? Nope. It just stays x plus 2. Now with factor by grouping, we take the term we took out and one of the multiple. So you see we have a clone here. We just take one of those. So we have x squared, we have x plus 2, and we already took out x plus 2. So, solutions for x squared equals 0, x plus 2 equals 0. Negative 2, 0. That's your answer.